So, first off, let me again reinforce using Excel is very, very helpful here rather than Google Sheets. Okay. Google Sheets is a pretty good approximation because they basically copied everything that Excel had up to 1995 because that was past the copyright date. No, I'm fully serious 100%. Though to be fair, Excel copied OpenOffice and stole a lot of that stuff. So yeah, to be fair. Um, there's a bunch of things on Excel that you cannot do on Google Sheets. Okay. For example, I can actually break up tables to have different data sets in them. So for example, if I wanted to fit a part of a data set with a linear regression, I can actually break this up into 3 series, one up to here, one up to here, and then another here. And then I could separately fit those. Okay. It's very, very useful actually. All right, now what I did here is I took my experimental data, and I always put my experimental data first so I can work on it easier, first in my sheet. Okay. Now I've actually frozen the top column, top row here, excuse me. Does anybody know how to do that? You go into view here, and you'll see there's freeze panes somewhere up here. And then you can actually freeze different parts of this so that they'll always be visible in your window. Okay. And so I find that to be very, very useful whenever you're working with more than about 10-ish, 20-ish data set. Okay. See the label's still there. I go down. Okay. Now, the first thing I need to put in here is VB, right? And so when I did this, you guys added like 20 milliliters in there. And then you had that last little area right before VE that you added increments in, right? Okay, so everybody good with that so far? Okay, now, I just approximated your data in the fastest way I could, okay? Because ultimately, the exact data I have in here doesn't affect the process that much, okay? So my data is going to look very artificial because it is entirely artificial, right? Your data will look more organic and will actually look a lot better and fit a lot better. Like, for example, mine's really shallow here. You will probably have a much sharper curve up here. Okay. Okay, so I have VB, that's the amount of volume of base I added, right? Notice it's very easy thing to do on a burette. That's why burettes are designed the way they are, right? So you can just read those off. Now, the other item I have here is I need my pHs. Okay. For everybody that used the older system, we're not going to use that data. Okay. You're going to use the data from the newer pH probe that turned out pretty good. Okay. So make sure you're all using that same data set. This has 2 decimal places. Did you guys see that I have everything showing as 2 decimal places? So how you do that is you highlight the region you want that to be. Okay. And you can actually hold down Shift and click to get it to highlight that region. Everybody see how I did that? Where I started up here on the top, Shift, clicked, and then it highlights up to my click. You can keep holding down click, the Shift, and you can actually use the arrows to further highlight. Okay. Now, once you have the region you want to format highlighted, okay, you can actually come up here, go to Home. See how it says number up here instead of general? So I changed that general over to number. My number happened to have 2 decimal places for it. If that's not true for yours and you need more decimal places or you need less decimal places or whatever, you go here to more number formats and then you can change the number of decimal places. Okay. Okay. Everybody good with that so far? Fantastic. You'll notice there's also a scientific method here. You can also do them in scientific method. That's no problem at all. I just prefer these smaller numbers to be kept in 2 decimal places because it's easier for me to read. Okay. Like, I don't care how you do it on yours and then submit it to me. It's not that much harder to read. Then I'm going to be like, oh my goodness, I can't read this anymore. Okay. Everybody good so far? Fantastic. All right, so once I have those data sets, you may notice I just copy VB over a bunch of times. Can everybody see that? Okay. The reason I'm doing that is it's easier for me to highlight two places to start my charts. And I can usually just get away with doing that. And so what I've done here is I've just relabeled. And you can actually just go equals and then click if you want the label to be able to be changed automatically whenever you modify things. For this, that's not a bad idea because you would want to put ML here, right? So you'd have the units. Okay. Now, never ever put units in the box. Did you see what happened? I broke everything, didn't I? Because that is no longer a number. That right there is text. Okay? Or another way of saying that is, how in the hell do you do math on a calculator with ML? You don't, do you? It breaks the calculator. Okay? Very common mistake I see people make when they're first learning Excel and using Excel. Okay, now I have my pHs, I have my VB. This right here is literally just a copy of the other column. See how I just did that? I put equals, and then I just clicked on what I want to copy. And then I went the whole way down. Okay? Mine has the AI add-in where it automatically like suggests things. So when I do that stuff, it goes like, do you want me to fill the rest of the way down? And I go, yes. And it does it. Okay? If you don't have that, or it doesn't do it, sometimes it doesn't detect. See how I changed my cursor? This is the normal cursor. Right? See that? Okay, I clicked on a cell, and I want to copy that on my way down. So see how it changed to that little plus sign? I click, hold that click down, and then I drag. See that? And it changes it to the exact same thing all the way down. Okay? Keep in mind, though, it brings the formatting as well. All right? Everybody okay with that? So that's how you can very, very quickly modify and change things in these sheets. I labeled this again to what I'm doing, and so I'm taking VB, I'm multiplying it by 10 to the negative pH. See? I use the hat character to denote that I'm doing the power of, right? And then I put that formula in here. See what I did? I took VB here, times VB. And then it's to the 10 to the power of. Don't forget your parentheses. I then put a parentheses, a negative, and I clicked on that cell over there. Okay? Let me go ahead and do that real quick so you can see. You see that okay? So if it doesn't have value, you just click and it fills it in. All right. Always complete your parentheses. It's a good habit to be in because if you mismatch your parentheses, just like any programming, it'll mess it up. I can't actually zoom in on that box up there. But what you're getting here is the volume base is the first value. And then it's an asterisk because that's the symbol for times. 10. This is that hat character, the little caret. Don't forget the parentheses. Parentheses, negative sign, and then the pH you got. Perfect. And in parentheses. By the way, if you mess up on these, it's not such a huge deal because you can always go in like, I forgot the negative sign when I first did this. I went, oh shit, those are big values. And so what you can do then is you can just drag these down and it'll auto-complete that same formula. If you look at these cells, you'll see that it's every time it's going into the next cell, it is selecting the next pair down. See that? That's because I don't have any dollar signs in it. And so it does not freeze anything on my formula. When I move my formula, it moves around with it. Okay? The things it's selecting move around with it. They'll move around proportionally to how much you moved the formula. Okay? So if I was to take this and I was copying it, and then I highlighted down and pasted, I'd get the exact same thing. Okay? Very okay with that so far? Notice that every time I change things, everything in my sheet's changing. Okay, because I have everything so it automatically calculates off the previous. I only have to change one set of data if I ever have any errors or I put new data in or whatever. Okay? Okay, now we have that right there. So we're actually kind of halfway to ready to make our grand plot. Okay? The next thing we need to do is we need to actually figure out, well, where is my actual VE? Because yeah, I calculated one, but I don't know the exact molarity of that NaOH, do I? Okay? And I didn't calculate it perfectly, did I? I did some rounding errors, and there could be other things in there that would affect my calculation, right? So that actual VE that I calculated, the VE I calculated is not going to be the actual VE, right? They're going to be two different things. Okay? Okay, so what I'm going to do here is I'm going to take the derivative. This is large delta, by the way. You can actually insert Greek characters. They're just a pain in the butt to do. Right? So I typically just put like a large D, small d, whenever I'm doing large delta, small delta. Okay? But what I'm going to do here is I need the delta for the volume. I need the differences in my volumes here. You don't actually have to calculate these, by the way. I did it so I could give you a chart that you could look at. Okay? This part you don't have to do. This part you do need. This is the first derivative. Okay? And so what I've done is I've actually just taken the change every single step. Right? So that is the second volume here minus the first volume, right? Those are in parentheses. I then divide by, excuse me, it's the pH here. The second pH minus the first pH in parentheses. I then divide by the second volume here minus the first volume. Notice literally I'm just doing a slope every single step. Mm-hmm. pH when we add 0 base? No. Okay. No. You'll have a very strange number if you do. Yeah. Especially in your guys's, because you went like 20 milliliters. Oh, you mean like change where the column is here?
Yeah, just like I wanted to move the column to match.
Okay, there's a few ways you can do it. See how I just went on the top here of what I highlighted? And it did this little arrow thing? Okay. You can actually just move it up that way. Yeah. The other way you can do it, if it's really large data sets and you're having trouble clicking on things, just highlight it. And then typically what I do is copy, unless I want the tags to move with it. And then I paste back up or further down, whatever I want. Okay. Did that make sense, right? This is that VB, the formula. VB times 10 to the negative pH. Yeah. I just put the formula because there's not really a good term for that, right? If the formula is too long, there's a few different things you can do. One of the things you can actually do is you can Alt-Enter, and you can actually write it in multiple lines. Okay. You can also wrap. So you can go up here, and you can actually hit, see how there's different things here? Where'd you go? God, I'm having difficulty seeing. It's so much easier on my home computer. Up here. First off, you can actually cause these to be higher or lower in it. And then you can actually cause them to wrap around. By the way, this conditional formatting is how I do that thing where it changes where it's highlighted. On the schedules. You could have conditionally formatted this thing to the highest value is what it highlights. Okay. So I've actually highlighted these here so you can see them easier. So see how I have my derivatives here? Okay. So when I'm looking at a titration curve, right, what am I looking at? So in this region, what is this? Before equivalence point, right? This region here is where you're looking for equivalence point, isn't it? Okay. And then this region's after equivalence point, and it would have leveled off if yours will level off. Mine does not because I faked the data, right? Yeah. Okay. So what we need to do is we need to find the place here that we had the largest change, right? The largest first derivative, okay? And that's going to be the place that our equivalence point is, isn't it? Because once we hit the equivalence point, every single drop of that base is changing that pH, right? Every single molecule of base changes the pH, doesn't it? Okay. Before that equivalence point, most of it gets neutralized off. And so see here how I have a string of values that are all 5s. They're the largest value in here. This column. Okay. Note this is going to end one earlier because we're doing 2 of the values, right? So if you go further, you're going to get a 0. You get these weird values here, and then you got to delete them out. Okay. Okay. So these 5s here, they tell me that this is my VE equivalence point region, and I always take the middle value, and that gives me my VE value. Okay. Everybody good with that? Mm-hmm.
And it's not like I know George sounds like people.
Mhm.
But I'm still getting like decimal point and not like a dramatic change.
So, what's your maximum value? It doesn't matter if it's 5 or if it's a decimal place. It doesn't actually matter.
Maximum would be a 0.3.
Okay. It really doesn't matter what these values are here. What are these values here on this side?
0.06, 0.06, 0.06.
Oh, so you have like a 10 times difference.
Okay.
Yeah.
Is it fine though?
Yeah.
0.3. You want a little more?
Are you using their data?
Yeah.
What's your value
Which one?
for the highest first derivative value?
Got 0.38. And then
Okay, wait a second. Are you ending 1 before?
Probably.
Okay. So if you don't end 1 before, the next value will be 0. You'll have a huge difference. Okay. Way up. And these numbers are correct, right? Like the pH number is correct. The pH number looks right. The VE number is really high. like really, really high. But yeah, that's still your highest one. That is your VE.
Okay.
It's still fine. It's just wow, we mispredicted that VE. Oh my goodness. My guess is somebody's made I don't one of the bottles that was involved in that NaOH was like half the molarity. Was significantly different. It won't matter here though.
I was just wondering, because I was like, what is it?
Yeah, I used the predicted value, obviously. Yeah, the 24-ish, that should have been. Typically in these, when you're doing these things, you would put your middle value, your VE, in the middle of the amount that'd be in the burette. And so it would be just shy of 25. That way, if you miss it a little bit, you have your maximum range that you can work with. But apparently not. Yeah, something went interesting there, didn't it? Okay, so let's look at what this looks like. So this right here, this is the titration curve. That's just these two values here. How you generate these graphs is you select the two columns you want to use. You can actually go back and fix this, and I'll show you how to fix this in just a second. But so I have my two columns I want to use. The first one's X, second one's Y. Okay? And then I go insert, and I go scatter plot, and I put in a scatter plot. I prefer not doing the lines usually, but you can do the lines. In fact, this first one actually probably would have been better with the lines. Okay? That's typically how you would put that in. I prefer to have the points visible so I can click on them. Okay? And get those actual numbers. And that's what that looks like. And then it doesn't have a title, so I go in here and I edit my title. And then I'd edit my X and Y's. Let's say that this did not fit down here. We got a 0, okay, on this X-axis. If you come up here, you double-click on the X-axis. You can also right-click if you need, if it doesn't open from a double-click. Okay. You'd format major grid lines, or format axis, excuse me. This will open here. Usually it opens on one of these. And then you come over here to the chart. And see how I can change my minimum here? So I zoomed my minimum in on where my data actually starts getting taken. Okay. If you do the 0, you have a lot of trouble seeing it. Okay. Okay, is that making sense so far? Okay. Notice again, you can actually come through here and do your labeling and stuff from this area and change your text options and do formatting and make it look really fancy. Okay. So you would want to label these axes, of course. I didn't quite have time this morning to do that. I also had to look at a few other things. But everybody okay with that so far? Okay, that's your titration curve. That's the last point in the lab procedure, in case you're curious. The next thing you're going to do here, you don't need to do this one. This one's a graphical representation of a derivative chart. Okay? So literally what I've taken is, this is the first derivative of those values. I've charted it for you, and then you can see that right there is your highest peak, i.e. the largest derivative, right? I.e. that's your equivalence point. Okay? So that's how you figure out equivalence points. You take that equivalence point. Okay? Notice you typically get like two values here. It's going to be the first one. That's the one that has the largest slope. the next one would be close enough typically that you can actually still get the equivalence point from it. You should notice that this value is not the same as your phenolphthalein, right? Which is your endpoint. It's slightly different, but not hugely different. Okay. Okay, everybody go with that part right there?
I'm sorry.
Mm-hmm.
Can you just repeat like the first thing you said about that chart? Because I'm just
So this is just, what I've done is, this is actually a first derivative chart.
do we need that?
No,
Okay.
no. It's just, it's useful for you all to understand what this actually looks like, right? So it's going to come up into a point here, because that point right there is your maximum. Okay? And that's that value right here. Okay. Okay. All right, so the next thing we knew is that is your VE right there, right? That's your equivalence point right there. So my VE was this one here. Okay? Your VE will be the, what was it, 50, 51?
Talking about milk, right? Like,
Yeah, whatever volume you recorded in. So it should be milliliters. Yeah. If you ever record in any other volume, it'll be. Okay. All right. So once you have your VE, you're ready to go on for the next step, which is the gram plot. You can't do a gram plot if you don't know what your VE is. Okay. So what I've done here is these are the VB and VB times 10 to the negative pH, right? That I need for my gram plot. Okay. Now, I've plotted that entire series of data right here, okay? And notice it is not perfectly linear, is it? It does not look like that nice gram plot in your book, does it? Okay? If you read the one in your book, it's for the last 10 to 15% before VE, okay? And that's actually what you need to do here. You need to have your VE, and you need to do the section that's right before your VE, okay? Because that is going to have a fairly nice linear relationship. Your data should be pretty nicely linear. My data looks awful, but still acceptable. I got a 0.91. So still acceptable, even though I pulled it out of my magic bag of tricks, right? Okay. I was actually kind of amused at me just guessing the numbers completely. Got it within about 10%. That's not bad. Okay, so first off, let me show you right now how to figure out how to change these things. Okay, do you see how when I highlighted this, it went into like chart design here? Okay, so what you can actually do is, well, first off, you can change chart type if you ever want. The other thing you can do here is you can right click on this and you can actually change your data set. So see how I right clicked on here, this middle part, and I hit select data, edit, and I can actually change my data set. So I can swap out a data set. Okay? It's very common to need to do when you're doing a gram plot. Okay? Because you need to do the last 10%, right? And you can miss that, or you can end up with values in there that it's very easy to end up with values. Okay? And so you just go in here. The last value is typically correct because that's the one that's going to be your equivalence point value here. And then these values are usually the ones you have to change. And so you just go 21 instead of 20, or whatever you need to change it to. If you click this, you can actually select it using the sheet.
for your plot, you're using VB and negative pH. And
So what I'm doing is I actually have a little part here where I put my VE.
oh, and that was from when
I figured out my VE down here. Yeah. So I took the number here and I plugged it in. So mine was 24.2.
Mhm.
Okay. And then what I did is I multiplied it by 0.9. So I got the 10% before it.
that tells you how many, like, what you're supposed to use.
Yep. And I went down here, 21.78. I ended up taking 21.8 here because that was my closest one after it. And then I used those values to generate. So these values right here are actually what I'm using in this grand plot here. See how they're highlighted here?
Mhm.
Okay. This is my X, this is my Y.
And
And that gives this plot over here. No problem. Now, the next part, you don't have to do what I did. I just found it easier to do that than writing. It's faster for me to do the calculation than it is to type. So once I have my grand plot, what I'm going to do here is I'm going to go to this chart design again. Ta-da, and add chart element and trend line. Now, I almost always just go straight to the more template options. See if I can get to actually let me do it. There we go. More template options or trend line options. And then linear, because I want a linear fit here, right? And then I'm going to display equation on chart, display R squared value on chart. Note, I do not fix my set my intercept because I want that to change. Okay. And that's where I got this right here. Okay. So see how that gave me my slope, my y-intercept. It also gave me my r squared. Okay, because I selected give me my r squared. If this is less typically than a 0.95, you would want to change your frame. Okay, it's not a very good fit. Okay, mine's less than 0.95, so I would likely want to change my frame. Okay. It should always be a negative slope for this. If it isn't, then you have done something incorrect. Likely you did not put a negative value right there. pH, yeah, negative pH. Because remember, your values are going to get smaller as your pH grows, right? Yeah, it has to end up. No, I honestly, like when I was first learned Excel, I went, oh my God, I can do all those repetitive problems so much faster.
Actually, it's best way for
Mm-hmm.
so not really.
I mean, you can do this in R. I don't care if you do it in R. I just can't teach you in R right now. And that's not a requirement for the course. I won't teach you in R anyways.
sorry,
Mhm.
I just asked you.
Mhm.
For the grand plot, you're doing your BB times 0.9 or point.
I do it times 0.9 because I want the literal value I need to start at.
Okay.
Okay. If you do it times 0.10, what it will do is give you the
Okay.
how much you need to go up, right?
So it looks like when I did that,
Mhm.
I get like a big pool like you did. Is that fine?
No, you'll get a smaller pool, yeah.
Okay, so you want. Okay.
You'll end up with quite a bit of a smaller pool.
Okay.
I mean, mine are totally fake data.
And you do. Yeah.
Mhm.
BB two, BB10 and BPH. BB, right?
Yeah, VB is X, so do that one first.
Okay.
And then VB times 10 to the negative pH.
Thank you.
No problem. And grand plots should always come down like this because you're going negative pH, right? So that pH value is going up. And so you're going 10 to the negative 5, 10 to the negative 7, 10 to the negative 8, right? And so those are smaller values. Okay. Notice my value is not very good. Hopefully yours is better. Because mine is totally made up.
And you said you want better R squared value?
Yeah, R squared value should typically be something like a 0.95. No? What do you guys get?
0.8835.
Okay, so what you want to do is how many data sets do you have coming into this?
Oh, I think that's good. I just selected all the data. So how do we take out the data?
What you do is you take this, you're going to put values in. So I'm going to get to a similar chart. So how I normally do this is I go to my 21.8 value. That's why I did 0.9 times it, right? So I could just look at the values. Okay. And then I go like that because I want both of those in my X and Y. And then I highlight down to the orange. Okay, that's my VE, right? Okay, so the next thing I'm going to do then is I'm going to insert. I'm going to go to my scatter plot and I'm going to hit scatter.
Okay, so I gotta. Because our VE was way above.
Yeah, it's 51.
51.
Yeah, it's fine. It doesn't matter. It changes absolutely nothing about this process. Except when you 0.1 times it, you're going to be 51 for your last value and 46
Okay,
something
so-
for your previous.
At 0.1.
Times your VE.
And then subtract that.
You don't need to do any subtracting. There's no more
51
math you have to
times
do.
1.
Yeah. Literally, that's your VB that you're going to go to. Period. That's it. Nah, if you do it times 0.9.
Oh, 0.9. Okay.
Yeah, if you do 0.1, you have to subtract.
Okay.
Yes. That's how decimal places work, right? Okay. Okay. Everybody got that okay? Okay. If your bounds are not coming up correctly, all you have to do is come down here to whichever bounds is not coming in correctly. And you go ahead and open it. I typically double click, but you can right click. You come over here to the chart area, and then you put in a value that makes sense for that. Okay. So like 21.7 here. And this should be like 24.3 or something, right? There we go. So yeah, nice and tight around it. Okay. Right. Notice again, this top one that you guys saw, that's if you take all the data. That's what that starts looking like if you take all your data. This one right here is the final section before the V.
That's the actual graph.
Mhm. Yep.
And you said we want R squared. Close. As close.
Ideally, it would be like, yeah. If it was really, really great grand plot, it might be something like 0.99 something.
And then
What did you all get, by the way?
for the R squared.
Mhm.
I may be wrong, but I got 0.9941.
Wow. That's really good.
On calculations,
Mm-hmm.
which we might have already been using.
Mm-hmm. Yeah, we really simplistically, what I've done is I've just taken you through these calculations.
Okay. Yeah,
We're
'cause-
now on the point where it says solve the formula for KA.
Okay, because it was like, draw a line through this curve and to the, I don't even know, to find, we already found.
That
it.
was this.
Okay, because I was like, what does that even mean?
So I just did it mathematically
Okay.
because it's easier.
Okay.
What you can also do is you can just take a line, literally a ruler, or you can use your line tool up here, add element to chart,
Mhm,
and you can literally just take a line and draw it down to the VE.
mhm.
See how it's 24.2
Yeah.
on mine? That's how you do it graphically.
Oh,
Now, if you're going to do that, what I'd recommend is you can add minor. So on here, see I had minor ticks.
mhm.
Add minor ticks so they're really, really close together. And then print them off in a nice big page. And then literally take a ruler. Okay. If you try to do it in a little tiny chart on a screen like this, it's not going to work well. Again, though, mathematically, you can take the first derivative. So if you take your first derivative, your VE is always the point that it changed the most. Okay? That's what a VE has to be. That's your equivalence point. Okay, did that answer the question?
Yeah, I was, so we basically just did, step one. Then the rest we can from plugging.
Yeah, so the next part is going to be getting the KA.
Okay.
So once you have your slope here,
Mhm.
that's my slope.
Mhm.
By the way, I've cheated a little bit. You can use a slope function in Excel. So I went equals, then typed in slope, and then highlighted that same value set.
Oh,
Yeah. So I'd have the exact number. I didn't have to type it. It's faster to do than typing. I again used the values from your book, but you actually have to calculate those values. Okay.
One more, sorry.
Mhm.
For the grand plot, do we use, so even though I got 51, do I use the two values after the 51 and? Like, we got.
For the grand plot? No.
Oh,
No,
sorry.
you do it up to V.
Okay.
Yeah.
Okay.
You'll see my title on here, 0.9 to 1 VE. The last 10% before VE, right?
So actually made our better.
Wow. The data actually worked out pretty good. Yeah, we definitely did it with something that was much lower molarity, but worked out really nice because then you had more points. So your grand plot is actually really good. Huh. Okay. Yep. And so then you'd have this formula here. You take your slope value. You need to get your gamma, your activities for both your species, your base, and your conjugate acid species, okay, or your acid and conjugate base species. You need to take the base form divided by the acid form for your activities. So if you look at your formula here, oh, stupid AI thing. Stop popping stuff up. Okay. All right. So if you look at the formula for this, it was this formula right here, right? Okay, see that? And so we had placed this in y right here. Okay. In terms of this value right here, we used the VB. And we didn't really have to do anything else with that. That's fine. Okay. And so what we've taken then is this right here times Ka. Okay. Everybody see that okay? And so the slope here is this value, isn't it? To get your Ka back out of that, you have to divide off this value here. Okay. So again, that slope on your grand plot is this value here. Okay. Yeah, we have to take that slope. We have to times -1, and then we have to divide it by this value here. The acid divided by the base. Oops. Actually, that. Yeah, you have to cancel those off. So you're going to take your slope times negative. Now, before you do this part, though, there's actually something we have to do. Okay? And that is this calculation right here for your values. Okay? I didn't see any use in me actually putting my values. I didn't have your guys' values. Nobody sent me those. Because there's already an example of calculations with fake values in them right here. So what you need to do here is we need to take and we need to figure out the actual ionic strength. That's number 1. Okay. And so you're going to take the, remember this is the potassium that goes with this part right here, right? The KHP. Okay. So potassium hydrogen phthalate. Okay. So you're going to take that value, that initial concentration you calculated out right here. You're going to get that into molarity by using the molar mass. Okay.
And would that initial be?
You got the mass of this, right? So grams, divide by the molar mass, that'll give you moles, and then divide that number by liters. And that will give you molarity. Okay? Don't forget the dilution again. You didn't use all 250 milliliters.
Yeah.
So you started with that initial concentration in your flask, right? Is everybody okay with that so far? Okay. And then you delivered in 100 milliliters, right? Everybody okay with that part? Remember you put 100 milliliters in there? Okay. Okay. So in a flask, you had 100 milliliters of KHP solution, right? Okay. That you made using 1 gram. Okay. Okay. So this is just that dilution factor formula, right? So here's going to be 100 milliliters. Down here is going to be the 151, I believe it is, right? Your VE value plus 100. See, here's VE is 19. Or 0.95 times VE is 19, excuse me. So this is going to be 100 plus 0.95 times your VE value. Whatever that is. Okay? Okay. Everybody have that? So 100 plus 0.95 times your VE again. Okay? Okay. All right. Now, once you have that initial concentration, don't forget to account for that initial dilution. Okay? Because you didn't use all 250 milliliters, right? You're only using the 100 milliliters here. Okay? Okay. So once you have that concentration with the 100 milliliters that you added, you're going to divide that number by whatever 51 times 0.95 is. Okay, sounds about right. That would be like minus 2.5 something. Okay, and so you'll have that new concentration. That concentration right there is the concentration of K plus. Okay. Okay, everybody have that so far? Yeah. All right. So the second part we have to do here is then we need to figure out the sodium, and then we need to figure out our acid and base forms. Okay. And so the sodium is going to be what you added. That's that same VE times 0.95. Okay, that's this right here, see? Okay. Notice that that bottom number is just going to be 100 plus that number, right? What did you guys use to measure out the 100 milliliters, by the way? Okay, so ideally you would have used like a you could have used a burette, you could have used one of the fixed volume pipettes, or you could have used a fixed volume flask, 100 milliliter fixed volume flask. Any of those would work really well here. The graduated cylinder means that the error of your measurement is actually huge, right? Because you have the error of measurement of graduated cylinder. Okay. So in the future, please remember to, if you want to do something very accurately, don't use graduates. Okay. So, anyways, everybody have that part right there?
And it would be 0.1 molarity because that's
Mm-hmm.
from the bottle.
You got it. And honestly speaking, this being a little off isn't going to really affect us that much. Because it's not going to change these numbers that much when we actually do the ionic strength. Okay. So the next part we have to do is we have to figure out the base versus the acid, right? And so remember, that is that fraction remaining. Everybody remember that formula? How close we are to our VE? So we're going to be here 0.95 of our VE, that point right before it. And so this one's going to be the remainder from 0.95, which is 0.05, right? Okay. And that's the 100 milliliters that you put in, right? Okay. And that will be the, whatever that number was again, 40 something, 48, whatever. Yeah, 100 plus 48, whatever. I'm just not going to remember it. And then you need to put your initial concentration again. Remember, it's the same initial concentration in each spot.
And that's to get that. 5 moles. 50. And we have to use the dilution.
So you would have not. Oh, okay. So this is the initial. These are the dilutions you're doing.
Okay, so we don't have to like.
Yeah. As remember that the 100 milliliters is going to have the same concentration as 250.
Okay.
Okay. Yeah. These are those dilutions.
Okay.
What happened in the lab is that you guys didn't do these when we were trying to figure out what the VE should be. Yeah. So this is what you should have done in the lab to figure out the VE, right?
Mm-hmm.
That equation had this part to it, the dilution factor portion. Okay. Okay, so the next portion to this is that's going to give you a very small number, obviously, because you've consumed almost all of your acid form, right? Okay, because we're very, very close to equivalence point. So the next part we're going to do here is, Jesus, this is going to be the whole lecture. We're going to have to go really fast next time, okay? So the next part we're going to do is we're going to take the base form and figure out that one. Okay, so that's going to be 0.95 because that's the fraction that's remaining of that form because we converted 95% of it to this form, right? Okay. And then it's going to be that 100 number because we added 100 of this stuff in. And then down here is going to be the 148 number. Okay. And again, that same concentration, that was the grams divided by molar mass divided by 0.25 per liters. Okay.
What's that concentration? Is it 0.02?
No, I don't know what your number was. Yeah, you guys weighed out a certain amount of KHP, right? And I don't know that number. So that would be the grams of KHP divided by its molar mass. And it's for this group here. So make sure you use their number. Yeah. It should be the same number as your data set.
Okay.
Okay. Okay. Notice you'll use that 3 spots there.
Oh yeah.
Okay, so the next thing we do here is we go ahead and calculate the ionic strength. That's that mu value. Again, each of these numbers is going to be different here for the concentrations. I don't know your guys' concentrations because I don't have that data. Okay. Okay, so you're going to take 1/2. This is then going to be a sum in here, so make sure you do this part first. Okay. And that's going to be the concentration you got for the first one. Potassium has a charge of 1, so it's times 1. Okay. And then you got the concentration right here for sodium. And again, it has charge 1, so you don't have to do anything else. Okay, it's 1 squared, it's 1. And then over here, again, you have the HP. That one has a -1 charge. And so again, it's going to be the concentration. You don't have to do anything because it's 1 squared, right? Technically -1 squared, but it doesn't matter. Okay, now the only one that's going to have a big difference here is this P2 minus. Notice it has a -2 charge, right? And so what you're going to get is the concentration of that times 2 squared, right? Which is 4. Okay. So don't forget to times the concentration of this P2 minus here by 4. Okay. You add all of those together, and then you divide by 2. And that's going to give you your ionic strength right here. Okay. Okay. Everybody understand how to calculate your ionic strength? Okay. Now, you'll then estimate these gamma values, the activities of each of these species for the base and, well, the acid and its conjugate base. You take the mu value that you got. You go to table 7.4 in your book. Okay. You have to get the hydrated radius. Notice these values right here are actually going to be correct for that right there. And you'll probably be pretty close. Okay. I wouldn't expect a huge amount of difference here. But the hydrated radius for the P2 minus is this value from that table for this problem. HPI is not listed, but if it's not listed, then what you do is there's only a difference of a hydrogen, right? This is a fairly hefty structure, and so we would use the same value here for the one that's listed. Okay. Okay. If you ever encounter that where the value is not listed, just use a very close analog. Close analog is going to be conjugate, the base form, right? So, okay. All right. So you go ahead and plug those in to the formula. And again, we have a charge of 2 here, -2 specifically. It has a 600 ppm. And so when you plug it into the formula with these values, you'd actually get this right here. on that table. And what you'd see here is that if we had a strength of 0.01, well, we'd be this value, right? So what we end up seeing here is we actually have to interpolate between these two values on this because we are not at a 0.01 and we are also not at a 0.05, are we? Okay. Okay. And so we're going to estimate our best between these two values. And does everybody know how to interpolate between two values? No? Okay. If you are the average between these two values, sure. But the easy way to do that is how I typically do that is I just take and make a chart, put a trend line in, or just figure the slope for it, and plug that into that equation. That's usually my easiest way to do it. So notice they're not massively different, but they're different enough that you're going to get a little error. Okay, so we estimated that value right there at our ionic strength for our experiment. So see how it's a bit between those two values. Okay. Now, the next thing you're going to do here, well, we take those values. We're going to take one divided by the other, right? Okay. And we're going to solve for our K value here. Okay. So take your slope, get rid of the negative sign, and then you're going to be taking this, and you're going to multiply by how do you get rid of these? If you have your slope, what do you need to multiply by to get that slope out? The activity of the A minus, right? Okay. You need to divide then by the activity of the HA, right? And that would give you the Ka from the slope, right? Okay. Once you have the Ka, you can compare that to your values in the back of the book for KHP. And then the last thing you're going to do here is you're going to go ahead and do these calculations right here in this little block. There you go. Basically these sort of calculations. You're going to do them for your Ka values. Okay. So we have our Ka, right? Okay, you can get into a pKa by taking the negative log of it, right? Okay. Once we have that Ka value, we can actually solve for 1/3 VE and 2/3 VE. Okay. And how you would actually do that is you would just take these values, 1/3 VE, 2/3 VE, so 1/3 times my VE, 2/3 times my VE. I'd come up and I'd just plug into these equations right up here. Notice I have my Ka here. I'll have to slightly recalculate for each of these points. How do I get this VB for 1/3 VE? I take my V and divide it by 3. Okay. You are like You all terrified or something? What happened?
The one.
Down here it asks you
Oh.
to do these for 1/3 VE. So from the measured slope of the grand plot, the values of the activities that we just talked about, calculate the pKa. So we got our Ka, we take the negative log of that Ka, that gives us our pK. And then choose an experimental point near 1/3 VE and one near 2/3 VE. So I take my VE, divide by 1/3, right? Okay, and I choose my nearest experimental value. Notice that will give me my pH there as well, right? So because I have my pH there, what can I do for my H plus concentration? Got it. I already have my H plus concentration, don't I? Okay.
You said for 1/3.
So that will be your actual value, is your closest value. It may actually be 1/3. Whatever's closest. Okay, how do I get my OH minus value, by the way?
Four, 14 minus the pH, something.
You got it, yeah. 14 minus pH, 10 to the negative at value, right? Alternatively, since I have my H plus concentration, I could just take 10 to the negative 14 divided by my H plus concentration, right? Okay, so notice that if you have that K relationship formula, right, this all of a sudden becomes incredibly easy to calculate all the points in, right? Because you actually know all the values, don't you? Okay. And so you can actually calculate then the pKa with each point because you already know all the other values. Okay, you know the activities, you know all these other things, right? Okay. Now, these values are not necessarily going to be perfect, by the way, when you calculate them. You'll actually see they'll be a little off, but they'll be pretty close. Okay. All right. Does anybody have any questions here?
Do you mind scrolling back up to that equation?
Mhm. Yep, calculation one. Don't forget, though, that you will have to do these calculations again. Okay? What you're going to be changing is these values here. Because you will no longer be at the 0.95 V.
Okay, and
Mhm.
just a quick question about that.
Mhm.
So I did the 51 RZ times point times 1/3 and I got 17. We don't have a 17 in the closest value.
Okay, you're just your closest value.
So will we use
25.
then? Okay.
Yes. Yes. Whatever value you have, it's close.
So we
Mhm.
use that.
That's fine. Okay. Yep, and you plug those in here. Don't forget that these values here are going to be based on how far you are along, right?
Mhm.
If you remember that formula, it was the amount along you were to the VE. Okay. So you won't be doing 0.95 times. Okay. This is equation one again.
Uh,
So you know almost all these values here. All you have to do is just plug them in once you calculate each one.
mhm.
And that's going to give you a Ka value.
Okay.
It won't be exact, but it shouldn't be horribly off. Like, it's not going to be 10 to the negative. It's not going to be 1,000 times. Okay. Does anybody have any questions? All right. I did record this in case you guys forgot something or whatever.